Dear students, today we are going to discuss about Smith chart. Okay, so Smith chart, so it is a graphical figure which is obtained by superposing the constant resistance circles and constant reactance circles. So within the unit circle in the complex gamma plane. So this gamma is nothing but reflection coefficient. Okay, so this Smith chart which was designed by Smith. Okay, it is mainly used for the easy calculation of the VSWR, reflection coefficients and input impedance of a transmission line problem. Okay, so in that we have two types of circles. One is constant resistance circles, right? So here if you see, this is the constant resistance circles which have the center R divided by R plus 1 comma 0, and with the radius, all these circles having the radius of 1 by R plus 1. Okay, so here the center R is equal to 1, right? So these are the constant resistance circles. Okay, so when coming to the reactance circles, right, so it should have the center 1 comma 1 by x and radius 1 by x. Okay, so it will start from this end, right? So this is the imaginary part of the impedances, right? So if it is positive means it is inductance, right? So if the impedance have positive values, then it is inductance. If it is negative values means it represents the capacitance. Okay, so if we merge this both the resistance circles as well as this reactance circles, right, so it is nothing but the Smith chart. If you see, this is the graphical representation of the Smith chart, right? So this circles which represents the resistance, and this line will represents the reactance part. Okay, so if you have load impedance, for example, ZL is equal to some 0.5 plus j 0.9, means you have to mark this real part. This represents the resistance in the resistance circles. Okay, so I will show you the Smith chart and solve one example. So this 0.9 which represents the imaginary part, right? So you should mark this 0.9 in this reactance circles, right? So this is the Smith chart graphical representation, how we should mark the resistance and reactance values, right? So what are the steps? So what are all the steps we are doing while doing the problems means, the first step is, so we should find the following parameters using the Smith chart: VSWR, reflection coefficient, input impedance. So the step 1 is, so find the normalized load impedance. Okay, so which is nothing but ZL divided by Z0, and you should plot that point on the Smith chart. So then we should draw the impedance circle from the origin, right? So it is otherwise called as the VSWR circle. Then draw a straight line from the center to the load impedance point. Okay, so I will show you how you should mark it in the Smith chart. So then this VSWR is directly calculated from the intersection of the impedance circle and x equal to 0 line on the right side. So let me see one example, right? So they should give the problem that determine the input impedance and SWR for 1.25 lambda long transmission line at the sending end, and with the characteristic impedance of 50 ohm, and the load impedance is ZL equal to 30 plus J40 ohm, right? So according to our discussion, the first step is to find out the normalized impedance ZL by Z0. Okay, so ZL is 30 plus J40 divided by 50. Okay, so if you are calculating ZL normalized impedance, it is 0.6 plus J0.8. Okay, so then we should draw the circle and extend the line outside the circle. Okay, so if we see it in Smith chart, right, Okay, so if we see the value of 0.6, right, plus j 0.8, right? So you should first mark this real, right? These are all the resistance circles, right? So you should find out where is 0.6. So here is 0.6, so this is the 0.6. Okay, so in this 0.6 we should have 0.8. This is reactance circle, so here 0.8 and here 0.6. Yeah, so and this is the point, this is the point. So here, so 0.8, 0.9, 0.9, 0.8. So this is 0.8 and this is 0.6. So this is the point of, this is the point of, this is the point of ZL by Z0. We should mark this first. Then from the center, right, you have to draw a straight line, right? You have to draw a straight line and you should draw, right, a circle. Okay, so keep this as radius and draw one circle, right? So I just draw roughly. Okay, you should use compass and use try to draw the circle. So after draw that circle, right, you should extend this line. So wherever it cuts, you should extend this line. Okay, fine. So if you draw it in compass, so it is exactly cut this point, that is 3, right? So we should mark this is nothing but VSWR. You should directly calculate it from this. Okay, so on the right side, so in the line x equal to 0 and where the impedance circle intersects, okay, this point is the VSWR. Okay, so the next thing is we have to find out the lambda given lambda, right? So 1.25 lambda. Okay, so if it is 1 means, so here see, so this is the wavelength towards the generator. Okay, it starts from there and towards the generator. So one complete cycle is 1. Okay, so one complete cycle it is 1. So 0.25, right? So you have to add this 0.25. Here you should mark the point as 0.124. Why it is 0.124? Because each one unit it is represented as 0.002. Okay, so from this 0.124 you should add 0.25. Okay, so if you see here, so the entire circle is 1 lambda, so 0.124, you should add this with 0.25, and if you are adding 0.374, okay, so you should mark this point, right, from the clockwise direction and draw a straight line from this point to the origin. Okay, that is nothing but the normalized input impedance. Okay, so this is the, yeah, if you see, so we should mark this 0.6 and 0.8 here, right, and draw a straight line towards this, and this point is 0.124, right? So 0.124 plus 0.25 is nothing but 0.7374. So it's here 3637374. So you have to draw a straight line here also, right? So you should have a circle, right? So radius, by keeping this as radius, and you should draw one circle right? And this is nothing but the VSWR. So this intersection point is nothing but ZS plus ZS by Z0. If you are draw in the Smith chart, you should have the cut at 0.6. If it is below this line, means you have to give minus because it is of capacitance value. So 0.6 minus J 0.8. So this is the answer. If you draw it in Smith chart, means you will get this. Okay, so to find out the input impedance, so Z is equal to, you have to multiply this 0.6 minus J 0.8 with the value of Z0. So you should get the value. Okay, so which is nothing but 30 minus J 40. So this is the value of the ZS. Okay, so thank you students. You should try it in the Smith chart, right? If suppose you have the answer as plus, right? So some if you see in some other example, right, if we have this point, right, after calculating means the length of the wavelength, so it is, this intersection will happens in the positive side, right? So this is due to the inductance, right? So then you should write in terms of plus J. Okay, so this is the concept. So we should calculate the VSWR and input impedance easily by using this Smith chart. So this is nothing but the graphical representation of this resistance circles and reactance circles. Okay, you should practice in home using the Smith chart. Okay, thank you.